Here is an example of a gas law calculation. Specifically, we're going to use the ideal gas law equation to determine the identity of an unknown noble gas. Okay, so we're going to be able to determine if this is helium, neon, argon, krypton, xenon, which noble gas it is from this example problem. Okay, let us begin. At 137 degrees Celsius, under a pressure of 3.11 atmospheres, a 276 gram sample of an unknown noble gas occupies 13.46 liters of space. What is the gas? So what is the identity of it? Okay. Whenever we start a chemistry calculation, a really important thing to do is write down all the values given. What we know the temperature is 137 Celsius. We know the pressure is 3.11 atmospheres. We know the mass of our sample is 276 grams. We know the volume of the gas sample, 13.46 liters. Okay. And what we're looking for is the identity. Okay, this is really important in chemistry. When you're given values and variables, write those down at the beginning. We need to know what is it that is given so that we can focus our calculation. Okay. So we're going to use the ideal gas law, PV equals nRT. Let's see what was given. The pressure was given. The volume was given. R is a constant. We know what it is. 0.08206 liters atmosphere per mole Kelvin. Okay, that's a constant that was given. Okay, so we have been given P, V, R. Temperature is given. One thing we notice about the temperature, it's in Celsius. It needs to be in Kelvin like our R, our universal gas constant. So let's convert this over to Kelvin, add the 273.15. Now we're going to use our significant figures. So when we add and subtract numbers, our significant figures are controlled by the digits of precision, the decimal. 137 has no decimal, so we're going to round this answer to just 410 Kelvin. No decimal, I'm not going to carry that 0.15. Okay? So now let's see what we've got. We've got a T, P, V, and R. So we can solve for N. Now N is moles. So pressure is 3.11 atmospheres. Volume is 1346. Okay, our R is a constant, 0.08206. And our temperature that we converted to Kelvin is 410. Okay, so we have that, and that'll give us moles. Okay, so let's solve this and see what we come up with. Okay, so let's go 3.11 times 13.46 divided by these two numbers, R and T, multiplied together, and we get a total of 1.244 moles. Now with our significant figures, we should round this to 3, so we'll say 1.24 moles. Now our question here was, what is the identity of it? Who is this gas? Well, what do we know about molar masses of gases? We know that a molar mass has units of grams per mole. okay, grams per mole. That's the unit on any molar mass. So let's take the grams that were given to us, 276 grams. Let's divide it by these moles that we just found, 1.24. Okay, that will give us the molar mass of this unknown gas. And our molar mass looks like 222.6 grams per mole. And now we did a little bit of rounding here, so they told us it was one of the noble gases. So when we look at our periodic table and we look at our noble gases, we notice that the noble gas radon has a molar mass of 222.0176, so 222 grams. Well, that's what we got. Our decimal slightly different because of limitation of 3 sig figs in these values here, which would mean this one should go to 223, and these values over here that were originally calculated. But we know it's a noble gas, and so we have just figured out that this unknown gas is radon, okay, which is Rn, element 86, atomic number 86 from the periodic table. So again, when we go to solve problems in chemistry, it is really important not to get frustrated or throw your hands in the air and in frustration. When you read a problem, write down the quantities that are given and label those variables. This is what we know. And then what we are looking for, in this case the identity of the unknown gas. Write down the formula that we're going to use, and then we can substitute in these what we know values into it and solve for an unknown.